Hello, thank you for having me. By profession, I'm a type designer, but I'm going to present about my ongoing PhD research. And I think I should mention my supervisors, Drs. Mary Dyson and Fiona Ross, and also for part of the research I was supervised by Keith Thumb. And I'm doing this at the University of Reading in England. So when I say I'm a type designer, I'll be speaking kind of bottom up. So from the shapes, from what's printed or what's displayed on the screen, to characters and graphemes. I might use slightly unconventional terminology. So there is a reason for that, but we can discuss that during a coffee break or something. So first, activity. I've run a series of studies where people were asked to do this task. Do you want to do this now? Yes or no? You can say no. So you will be shown a series of groups of 3 letters, and you have to pick the odd one out based on shape similarity. And now just shout it in English, I guess. British English. Yeah, it's simple. It would be better if all of you shout. It's not always clear, as you can start to notice. Yeah, I'm selecting my own opinion here, so don't feel pressured. There is no wrong answer. And this is interesting because I thought this one would be this one is not the difficult one. No. So you see, you are already developing some sort of criteria for judging this. Ha. And this one is particularly difficult to judge, right? Because based on what? So I wanted to show you this before I go and explain what I think is going on. So the research question is whether a single theory can explain coherence in typeface design for different scripts. So that's just the shapes, not the orthography. What I mean by coherence is the similarity relationships between different character shapes. And why is it of interest? Basically, introducing coherence is the main skill of a type designer, and generally any kind of designer designing any addition of things. They need to belong together somehow. Well, whether they need. Sometimes it's perceived as an aesthetic measure. Sometimes it could be perceived as a marketing measure. In type design, it can be seen as a ergonomic, readability aiding measure. But that's to be really confirmed. So I focus on perception by readers and on typefaces for continuous reading, as these tend to be a bit more conventional and can tell us more about the conventional shapes of character shapes for a particular script. And I focus on 3 different scripts. So there's been some studies of letter recognition and letter similarity. I would like to emphasize that this research is about character similarity, not character recognition. So what they do is they challenge perception or often focus on Latin script only, or often focus on uppercase. And there is no systematic approach to context. So what you have seen, the task you've been given kind of encouraged you to pick two characters which are more similar and disregard the third one. So that's what I mean by judging similarity in context. Of course, it's a reverse. You could also see it as a task finding the most different character in 3, right? That's it's pretty clear, I think. So this is the research design, research structure. On one hand, I collected data from studies with participants. And on the other hand, I'm creating computational models to predict participants' responses. And I'm working with multiple different typefaces, and I have to reduce the set of characters I'm working with. So I'm focusing on basic English alphabet, and for each of these typefaces, I've selected 8 characters, which I then combine into the triplets. So and same for Cyrillic, and same for Devanagari, where I could not manage all the conjuncts, vowel marks, and everything. So this is just a basic consonants that are used for writing Hindi. There's been quite a lot of participants. They were recruited online. They had this task online on a special website. And I've collected also some background information. So from that I can deduce how many of them are native readers or fluent readers. The method is quite... They had to identify themselves as a native or fluent readers of particular language. Then I mapped the language to particular script. Also, I was interested in their profession. So I didn't want to test only on type designers. So mostly in the studies there were non-designers. And I didn't say it before, but it's apparent that mostly they were native or fluent in particular script, in reading particular script. So first thing you can deduce from the studies is you can collect the response frequencies and then pick the odd one out, the most popular response, and have a look at that in overall for each script. That gives you some indication about how difficult the task was for the participants. So 1 says everyone knew what to answer. 0.33, that's 1/3, says they were equally divided. No one had a clue. And it seems that for Devanagari, either people didn't know what to do. I think I might have some grammatical errors in the instructions, which is embarrassing. Or possibly the task was more difficult. So here's what's basically the raw data. For each triplet, the participants were shown. I know how many of them responded to what letter, consider them the letter the odd one out, or the character the odd one out. Based on that I can get a response frequency, and based on that I can get a confidence interval, which tells me, based on the collected data, where roughly would be the population mean. So how would the general population respond? So for example, I tried here to provide some, how to put it? I think the top ones are those where there was one really clear answer. So for Latin there is G, H, and M. These are actually in the second column, these are the actual shapes the participants were shown. Wow, we're in half already. So for the Latin, you see that when people saw the triplets G, H, and M, and this was randomized for each participant, they mostly responded that the G does not belong among the three. Or, for example, when they saw G, M, and Q, you see that there is G, M again, but because there was a Q, suddenly the task was much more confusing. So they were either picking G or M. We can hypothesize that it's probably because G and Q have a descender, and then they felt they are more related than M. Whereas in the previous case, H and M are clearly related because of the shape. In typography, we call it the shoulder, or the arch in the stem. And same for Cyrillic and Devanagari. So how to read this table? So for G and H, you actually get the similarity value, or from how M is different. I mean, for this particular task. And then there is the confidence interval. So in this particular task, G and H are quite different. So if there is, when it's near zero, the similarity value, it means the pair is different or considered different by the participants. And when it's near one, it's perceived as very similar. You can aggregate this data even further into something psychologists might know, and it's a similarity matrix. At the junction of each column and row, you get a similarity of the pair, which is, this is useful mostly for comparing to other studies. But it's a reduction of the data, right? I simply aggregated all the data for particular triplet in all the different triplets where it appeared. And again, the same for Cyrillic and Devanagari. And this is done for, I think 12 typefaces in Latin, 8 typefaces in Cyrillic, and 8 typefaces in Devanagari. So it's quite a lot of data. And then you can go even further and develop something I call similarities, coherence scale, which gives you some indication about how the characters are different from each other. So now for the computational model. So how much time do we have? 8?
5 minutes.
5 minutes?
12.
Well, perfect. Perfect. So I'm developing something which is generally called feature-based model. Each character shape is represented as a set of features, and these are then compared. There are two kinds of features, parts, ones that I call parts, and those that I call roles. Essentially, if I observe something in the characters that is similar in a few of them, but there is at least one character where it doesn't appear, I create a feature and create character concepts in the model to represent this similarity relationship. Parts are specific. They always refer to particular subshape. So it could be serif, stem, rounded part, and so on, diagonal part. Whereas roles, this is naming adopted from the work of Douglas Hofstadter, are more general. They're more like a phenomenological attributes. I have just a few of them. Possibly you could introduce more. They either refer to a compound shape, such as the shoulder, which is the arch and a stem, or they refer to overall qualities in the characters. I'm not concerned with color, position of the parts, precise edges of parts. Simply, if something looks similar, it is similar, and it is worth tracking as a feature, regardless whether I can find precise edge for it. I'm disregarding imperceptible details. So this method is based on craft knowledge, really. Type designers are taught and are used to perceive character shapes as series of strokes, like as in calligraphy. This is perfectly exhibited in this illustration of Metafont by Donald Knuth, which is a tool which uses stroke as the main construction element for character shapes. But also type designers tend to disassemble characters into parts which are a bit more fixed, or the idea of deconstructing letter forms in this fashion. This is interesting work by Deborah Adams from the 90s, and a bit more recent work by Roger Hirsch and I don't remember the first name, and Tamir Hassan from Lausanne. And this is the work of Douglas Hofstadter, where he shows different levels of conceptualization of character, from very abstract to very concrete, which is what I call character shape. He has several different levels: conceptualization, concept, and character plan. And also, this is very common illustration many typographers would have seen of typical global typographic attributes. So I'm using these kind of theories to represent character, to create character concepts for each character shape that appeared in the study. Some of them, they can naturally use the same one. So although the typefaces are different, the letter E might be, because of the simplification, I can represent the letter E with the same concept in different typefaces. And again, the same thing for Cyrillic and Devanagari. So I'll go a little bit back. So the black represents the strokes, the red symbols represent other non-stroke parts, and the turquoise color represents the roles, which are somehow there. Of course, they are a bit more vague. So then, how do you calculate the similarity of any two character shapes in this? It's by comparison of the features. So on the right side, on the left side, there is the letter A, which is represented by a set of parts which includes bulbous terminal, sweep, stem, another sweep, slope. That's the diagonal, sweep, and so on, and the two rolls at the bottom. And then on the right side, there is a letter B done in a similar fashion. So I look at the features they share, and from that I can conclude similarity of these two character shapes. That's pretty common formula for feature-based systems. Well, it becomes a bit more complex when there is a third character. So we can divide it into two separate tasks that people respond to. First, they say how similar the letters A and B are, but now it's within the context of three characters, so there is more features possibly because of the third character. And the second task is how different is C from both A and B. So on one hand, through the Venn diagrams, you can see that it's the part of C that it's not in A and it's not in B, but it's also the part, it's emphasizing the part where A and B are similar, but in a different way than they are similar with C. Does this make sense? Okay. So I have this nice chart and nice formula. It all looks really neat. But the problem is the features have different salience. Different features have different importance for the participants. And also, the salience could be locally different. So some feature could be more important for the letter A, but less important for the letter N. But also in overall. For the local salience, we can somehow approximate it by saying bigger features are more important. That's not exactly a precise thing, but we can approximate it. But we don't know the global salience. So what I've done is a little bit of machine learning. I took part of the data and used it to train a model. I can discuss later how this was done. But essentially, you create, iteratively, you create a hypothesis about the global salience, and you test it against the data. And the closest you get, the best global feature saliences you have. So, and then I replicate the results. So on the left, you get the results from the participants. On the right, you get the formula from how I compute it using the model. That's just too technical, I guess. And then you can compare. How do you compare? You can compare if the model picked the same odd one out. But that's easy. You would like to know whether the model can predict sort of the frequencies for different participants. So if half of you would respond to one test, let's say test MOP, and half of you would say M doesn't belong there, and half of you would say P doesn't belong there, I would like the model to tell me it's 50%, 50%. So I've tested it separately for sans serif typefaces, for serif typefaces, and for all, for Devanagari, for low contrast, high contrast. So what we see here is the results for a model which was based purely on parts. So no roles, nothing general. And the model can predict roughly 50 to 75% of your responses. So you would get it wrong every fourth time. Otherwise, you're easy to read. With roles, it improves, and the model can get it up to 80%. I think, considering this is fairly simple way of doing things, this is quite impressive and tells us something about how we are taught similarity, perhaps how we are taught reading and writing. But what's interesting is that during this process, I've learned these global saliences. So now I can tell what are the more important features for your similarity judgments. And this is extremely interesting for type designers. So we would need to know on which features to focus when we are designing typefaces, when we are making them click together. And I wanted to talk about neural networks, but I don't think that's a good idea. I have done some experiments with neural networks last year when I was here in France, in Nancy, and the results were quite promising. The only problem is that although we can look into the neural network somehow, it's really difficult to explain what is going on. So you can get results around 70% success rate for the odd one out, but we don't know why. We don't know why the model did it that way, and yeah, that's kind of the point. So in conclusion, there's been I think, of course, I haven't seen all the data sets, but I think this is very large data sets of similarity judgments using different typefaces, different scripts, variety of participants, and in, let's say, non-challenging conditions. They were asked to respond quickly, but there was no brief exposure, there was no blurring or scaling down characters. The characters were as you've seen them, basically. So I think that's going to be quite useful for further experiments. The feature-based model provides very good predictions. I think 80% prediction of similarity judgments of human perception is very good. The problem is we don't know whether the model, can we get up to 90%? This has been tested on all the data from all the participants. So I don't know whether the model is bad or whether people are bad at this task. So at some point, I will need to start filtering the data, and I really try not to do this because you cannot really say whether one perception of one person is better than another perception. So it will be interesting, another 10%. And it does provide explanation, whereas the neural network models don't really easily provide explanation quite yet. Yeah, that's it. Thank you for your attention.
It's a common complaint that convolutional neural nets don't provide internally explainable results. But I'm wondering, even in the earlier pattern recognition-based approaches, whether you have a clear sense of what's going on. Because this feature-based, well, this task that you've defined for your human subjects seems to be something that could be approached in multiple different ways. And I don't see any evidence so far that there's a homogeneity among the subjects in how they've elected to interpret the task that you've given them. So I'm wondering whether you've done any, first a kind of clustering-based or unsupervised analysis of the data in order to try to determine subtrends within the overall sample that you've collected, as to whether they're using, the phonetic interpretation in their native language or certain physical features.
Right. They were specifically instructed. Sorry. Yeah. They were specifically instructed not to use any phonetic interpretation, to focus purely on the shapes. I definitely want to do some cluster analysis, and it does make sense. I think I'm not trying to say that people necessarily perceive this way. What I'm trying to say is that the craft knowledge can help in predicting their responses.
But to tell a group of human subjects, whatever you do, don't use phonetics, it's priming them. That's a terrible experimental design.
Sorry?
You can't just sit people down and say, whatever you do, don't use their phonetic values. That primes the human subjects. You might as well tell them to use phonetic values. So
I don't see why that's
tell small children not to do something, that then they do it. And it also applies to adults in a certain amount. Yeah.
Okay.
So
I see your point, that they cannot help themselves. Yeah. I think in some of the errors you could see that, but definitely there. I guess that's what I was trying to show with one of the earlier charts I needed to run through. People did get the task right. In most of the responses, there was a dominant response. And so they were tasks they clearly understood. They clearly understood the task for most part. And,
I think that's the kind of analysis you need to do more of.
Yeah.
You know,
They
is there a
definitely
dominant
knew what they were
answer? How
doing.
dominant is it?
Yep.
Yeah.
Thank you.
Just out of curiosity, why are you using this font?
Which one? This particular one?
For your
Well,
any particular reason?
we designed it, so. I can tell you about the selection of the typefaces for the studies a little bit more, if that's what you're interested in. Yeah.
You explained why you selected only a few letters from each typeface, and I kind of understood the reasoning there, but it essentially makes it. The result is essentially that you cannot compare typefaces, and you cannot really compare letters in a typeface independent way. Have you thought about other ways of doing it, about kind of just asking all across the board and then somehow getting the necessary results out of that in a statistic analysis of some kind, or?
I'm not sure if I'll respond exactly to your question, so feel free to add more. This was, I think, the trickiest part. I guess psychologists would just take a pool of typefaces, pick triplets randomly, and notice that these triplets were always selected from the same typeface, because I was interested in the relationship within one typeface. And they would select randomly. But I think this is a bit of a problem, because characters or scripts are not a population. So I was worried that I would get, perhaps by random selection, I would get many easy combinations and very few difficult ones. So there was a little bit of system there in selecting these. I definitely want to run extra studies with some random selection. That would be perfect one for confirming or questioning the results. Would that help? Or or we can follow up later.
I think that what you told about neural networks is valid for feed-forward networks. But if you use a pure convolutional network, if you choose your poolings carefully, then there are techniques for finding exactly which neurons are activated. And people are more and more interested in finding exactly which are the intermediate structures which made a recognition possible. So I think there should be tools, and if they are not there right now, they will be in a short time, allowing better use of convolution networks. But this is specific to convolution networks, and it's used for shape recognition in artificial intelligence. So this is something you can do.
Are you referring to, for example, if we train the neural network to recognize cats, we'll start seeing features like eyes, rounded head, and
Yes.
Whiskers, and so on. Essentially, that's on this slide. So I'm viewing the layers of the and I don't know how would you call it, templates, patterns from the convolutional network. And this is not very useful to me. So I'm doing something wrong, obviously. Or I just don't know how to interpret this. So I think I just need to do a better job at using convolutional networks, or they are better at, when I use them for a classification task, I get this result, but this is not exactly a classification task. So I'm thinking maybe that's the reason why I'm getting this sort of strangely ambiguous pictures.
Well, I think there will be techniques
I hope so.
to do that.
Thank you.
Okay. Okay, very last question.
Now it's on.
Is your aim primarily to make character discrimination that is reading easier, or is it to make typefaces more beautiful?
If I had to say my goal, like in 25 years' time, I hope this research contributes to making type design simpler, possibly approachable for anyone. If you think about it, we are starting to write on digital devices, so we've been in a way alienated from our handwriting, of our personal expression in writing. So if we could reintroduce that back in the digital world, that would be something interesting. And I think it's going to happen in a few years' time. And there are already projects like Prototypo, which help you design typefaces easily, just based on your preferences. But it's still something only designers can do. They need do well. They need to learn it, and it takes time. So if this could contribute towards that, that would be definitely interesting. And if this leads to automation that, for example, automates language support to some extent, say that there would be a system right in your operating system, right in your computer, in your operating system, that is able of adding missing characters, that would be super useful in many contexts. But for that, we need to understand the relationships between the characters. Maybe I should have started with this. Thank you.
So, thanks again.